All right, so let's go ahead and graph this equation here, guys. We already found our points. We're going to go ahead and use a table here to graph. Once again, our middle point here is our vertex, and then the other 2 points represent any other 2 points in this case in our graph. So let's go ahead and do a sketch here. This is X, this is Y. Let's go ahead and do some labeling. So -1, -2, -3, -5, -6, 1, 2, 4, 5, 6, -1, -2, 1. So let's go ahead and start off with our vertex here, guys. Vertex is the point 2, -6, so which means we're going to be 2 to the right, down 6, which is here. Now the other point in this case is 1, -2, which is here, and 3, -2, which is there. So once again, guys, we have our vertex. Let's go ahead and connect our points. And in this case, our vertex here will be considered a minimum. All right, so let's go ahead and work on the next one, guys. And here is the next one. Now, in this case, guys, I did talk about this yesterday in terms of the warm-up, which whenever we're working with fractions in this case, guys, once again, whenever we're working with fractions here, we want to go ahead and multiply by a multiple of our denominator to get a whole number as our answer. So let's go ahead and get started here. So in this case, guys, first thing we should be doing here is we want to go ahead and identify the vertex. So our vertex in this case, guys, once again, is the point H and K. And H and K in this case, guys, H is the opposite, which is now a +4, and K is a 3. So we have our vertex. Now let's go ahead and create a table in this case, guys, table of values here, and we have X and we have Y. X in this case, the vertex, guys, is going to be in the middle of our table here, and that's going to be 4 and 3. Now, tricky part in this case comes because we do have a fraction, so we have to, whenever we substitute in an X here, whatever we get inside has to be divisible by a 2. So once again, it has to be a multiple by 2, and if it's a multiple of a 2, then it's divisible by 2. So in this case, what number in this case can I substitute here and subtract by 4 to still give me a number that I could divide by 2? So in this case, there's many. I could actually use, we're looking for numbers that come before and after, right? So that's what we're considering here. So I could actually use a 2 and a 6 because once again, both of these have the same distance from the vertex, which is 2 and 2. We could also use 0 and 8 because both of those in this case have a distance of 4 from the vertex. So really it doesn't matter, but I'm actually just going to go ahead and stick to 2 and 6 here. So let's go ahead and check here, guys. I'm actually going to go ahead and do X equals a 6. So if we want to solve for Y, you do have to substitute one of these values into the equation. In this case, guys, I am choosing 6. So wherever I see an X in my equation, I'll be substituting in a 6. So this is actually going to become f of 6 equals 3 over 2 times X, not X, but 6 minus a 4 squared plus 3. All right. So let's go ahead and solve this, guys. Once again, we're doing a order of operations here. So we do parentheses first. And from there, we're going to go ahead and do exponents. So 2 squared is 4 times 4 plus 3. Now, in this case, guys, because we have a whole number times a fraction, we actually want to go ahead and convert this whole number into a fraction. So I'm actually going to write that over 1. And the way we multiply this is top with top, bottom with bottom. So in this case, that's going to be f of 6 equals 3 times 4 is 12, 2 times 1 is 2, plus a 3. So 12 over 2 in this case, guys, is going to give us a 6. 6 plus 3 is 9. So what they're telling us in this case, guys, is that when x is equal to 6, y in this case is 9. Now, let's just verify that with the calculator. Once again, I'm going to go ahead and type that in the calculator. So I have 3 divided by 2 times, instead of it being 6, it's going to be 2 minus a 4 squared plus 3. And in this case, guys, we get an answer of 9. So like I said, guys, it is the same thing. So all we have to do in this case, guys, is graph it. So let's go ahead and graph this. Go ahead and graph it. And because all of these are positive, it's actually going to be in the first quadrant. So let's go ahead and graph it here. Alright. So this is x, and this is y, and this is 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 7, 8, 9. All right, so 9 is up here. So it's 1, 2, 3, 4, 6, 7. Oh, I counted wrong. 7. 7, 8, and 9. So 8 and 9. And then this is 1, 2, 3, 4, 5, 6, 7. And this is -1, -1. So let's go ahead and plot our vertex, guys. Vertex is 4, 3. So let's go ahead and go to 4, 3. So 4 and 3 up, which is here. And then the other points are 2, 9, which is here. And then 6, 9, which is there. So let's go ahead and connect that, guys, and that would actually be our parabola. That would be our parabola there. All right. Didn't come out pretty, so let's try that one more time. All right, close enough. So in this case, guys, that would be our parabola there. So you do have this practice problem, and a hint for you guys here is go ahead and rewrite the equation here. They're actually not giving us an h value. So I'm actually going to go ahead and rewrite this in this format. So go ahead and do it from there.